So yeah, thanks. So I wanted to quickly introduce the Axion searches that's happening here at Yale. We use a lot of quantum sensors and techniques that are developed for what today is being used for quantum this and that. So I won't go too much into that because we have an expert who is working with us. But I wanted to introduce what the physics is and how we use these technologies. And so it's not just me. So Professor Lamoureux started a haystack experiment here. We have Conrad, myself, Charles Brown, Sean Barrett, who's doing condensed matter, Keith Baker, Carson Beekeeper. So all of us are working on various aspects of this effort. And then we have lots of, you want to raise your hand if you have anything to do with Axions. So you can ask any one of us how we do. So there are three main, we have three different names, I guess, and it's a little bit separate, but all related work happening here. So the first one is haystack. So this is an experiment that is running and taking data every 5 years or so. We have like a major upgrade with completely new technologies. And Conrad, will you talk a little bit about some of the sensors that we?
I am prepared to say, I'm afraid to sort of give a brief update on what comes next after the pictures that are up on the left side of the slide.
So you can read all about it, and you can also read Kelly's thesis work that is in that Nature paper that's referenced here, and we have another paper in to PRL that Siran led, and so that will appear in PRL soon. We have Alpha experiment, which is the generation after that. We have added more collaborators, and it's kind of the next evolution of this Axion effort. And then we're developing photon sensors with Rydberg atoms here. So this is Eleanor's work. So what are we doing here? So when you hear Axion talks, you'll see a picture like this. So what this is showing is a coupling between axions and normal matter that we know of, which is photons. So GA, gamma, gamma, A being axions, gamma being one gamma being a gamma ray or a photon. So two gammas. And that's plotted against mass of the axions that we think that is plausible in the world that we, and then there's a bunch of limits set by cosmology, astrophysics, observation, various experiments. So there's a set of experiments that happens sort of in this micro EV kind of scale, and what we're going after is in this area where the axions, the mechanism for the axion being created, we call these post-inflationary QWAY breaking. And then there's a whole another set of experiments that is happening that is assuming that they were formed with this pre-inflationary scenario. And there's a big effort going on at places like MIT and SLAC with that. So we're going after this these higher masses because there's a big effort for the lower masses. I decided to just quote Michelle Obama and say, when they go low, we're going to. Okay. So I think I'm kind of out of time, so I'll hand it off. But there's a lot of us working here. It's a really fun group, and I would love to tell you more another time.
Reina, any questions, comments, axions?